Hey everyone, I'm Marina Jurica and I am joining you live from NASA's Jet Propulsion Laboratory here in Southern California. And we're going to talk to you a little bit today about the SWAT mission, which launched from Vandenberg Space Force Base last month. Now, the SWAT mission is a joint mission between NASA and the French space agency CNES, and it is going to track water on the Earth's surface at over 90%, which is pretty amazing. Now, joining me in just a few moments is Christine Gebara, who is a test and integration engineer here at JPL, and she's going to tell us a little bit about basically what SWAT has been doing since launch. She's going to give us an update, and we're going to be just eagerly awaiting all of this SWAT science data that's going to be coming down here in the next few months. We're also going to be answering some questions from you that have come in over the last couple of weeks, and we're going to be discussing SWAT with Christine here in just a few seconds. So just bear with me because I'm going to invite her in here to our chat from our sister station, which is at NASA Earth, and then we're going to come alive and be able to tell us all these really interesting things about what it's doing orbiting the Earth right now. So we just invited her in, and there she is.
Hi, Rita.
Hi, Christine. How are you?
Good. How are you?
I'm doing great. Well, I've got a 1/3 scale model of SWAT behind me here. So you're going to be able to talk a little bit about that, but you're in a really interesting, cool location on lab. So tell us where you're joining us from.
Yeah, I am at the top of the hill here at NASA JPL in the Advanced Deployable Structures Lab. This is actually where the deployable antennas on SWAT were first prototyped and tested, but we test all sort of deployable space structures up here. So right here is a little paper concept, kind of origami, of a technology we're developing here called Starshade. And what we do for all our projects here is we start with small prototypes and we make them bigger, like this origami behind me. So this.
So it's like a flower waking up.
Absolutely. So I just closed it, but in reality, it's meant to deploy in space. And then over here on the right is an even higher fidelity, more mature technology prototype that we have here. And so, yeah, that's what we do in this building.
And when you say it's on the top of lab, it really is. It really, hundreds of acres here, and you have to hoof it all the way to the top of the hill to get where you are. So you're in super shape.
Yeah, absolutely. We call it the ALPS, the Advanced Large Precision Structures Lab, and it's a pie, but absolutely.
Climbing up the Alps for sure. And that's also where the Karen instrument was born, right?
Absolutely. So the Karen instrument is a radar interferometer that uses two deployable antennas, and the antennas kind of are one on each side of the satellite and deploy out. You can see one kind of behind your head poking towards you. Yeah. And this building has a grid of structure on the ceiling, and we can hang things off of it to simulate the microgravity of space or of orbiting Earth. And we'll test the deployments using that grid. So we actually built a prototype of the booms in this building and made sure that we could deploy it before we actually built the real thing to send to space.
Now, SWOT stands for Surface, Water, and Ocean Topography. So tell us a little bit, Christine, about what it is and what your role was in this mission.
Absolutely. So SWOT is an Earth orbiting satellite, and it'll do the first global survey of Earth's surface water. And so what that means, it'll tell us to a level of precision and accuracy that we haven't had before, where the water is moving, how much water is where, and how that water may be ebbing and flowing in our lakes, rivers, seas, and oceans. And what I did on the project, I've been working on a great team of American and French engineers, along with many other partners, to help integrate and test the satellite. What that means is I helped assemble the mechanisms when they were tiny piece parts, and starting with like a Lego kit all the way up to a giant satellite, we would assemble something, then test it, then it would get bigger, go to the next level, and assemble it and test it until we had the entire satellite. And what we would do is we would put it through environmental testing, which means putting it in a thermal vacuum chamber to simulate space, or putting it on a vibration table to shake it to simulate the rocket and make sure nothing would break. So when we sent it to space, we were confident it would work.
And that's what it is doing right now.
Yeah, absolutely.
So tell me a little bit about where SWAT is right now, and what are the next steps that have to be taken?
Absolutely. So we launched SWAT a little over a month ago, and since then, we've deployed the solar panels, we've deployed the antennas, and or some of the antennas. There's lots of antennas on SWAT that don't deploy. And the team in mission operations in Toulouse, France, has actually been slowly turning on the satellite, making sure all the temperatures are reading right, making sure all the instruments are behaving the way we expect them to, and kind of learning how the satellite operates in space because it's in a new environment. And it's been really exciting to get the updates and say, oh, this instrument's on, here's the first little bit of data, and seeing something that we've worked on the ground for years doing its job and outside of a clean room.
And for folks who are just joining us, we're with Christine Gebara, and we're talking about the SWAT mission, which is a satellite that we just launched over a month ago. And folks at home, they don't realize that this is a pretty lengthy process to turn this thing on and get it working, and then make sure that it's working properly and correctly.
Yeah, absolutely. So SWAT actually is kind of in the commissioning phase and will be in a calibration orbit for almost 6 months, where it's kind of going over the same part of Earth over and over again and calibrating itself to known targets on the ground. And so that when it finally starts doing data for all over the world, we really know that that data is good data and true science.
And as you mentioned, we had a video camera at launch, which was pretty cool. And as it was getting deployed, and you can see a bit of the solar panels right here behind me, as you pointed out, Christine, and a bit of the Karen instrument, which is the main science instrument on board. Tell me a little bit about it. And if you didn't get to see the video, head back to our social media accounts and watch it, because it was really cool. It's the first time we've had the video on an Earth satellite, which was awesome. But tell me a little bit about how these instruments deploy, and tell me a little bit about the instruments themselves on the spacecraft and why they are next generation.
So I'm going to talk about the deployments, and then I'll talk about the instruments a little bit. Our French partners at CNES actually built the solar panels that deployed out, and those provide the power. And those are actually huge. They're about the width of a tennis court. And so they deploy out, and when you see that, you know the satellite's going to get power, it's going to stay warm, and it's always like you're like, okay, game on a little bit. And the Karen antennas deploy, and those allow us to do the good science, the new novel science that the Karen instrument will do. And actually, those antennas are so big that we can't fully test them on the ground. We test them kind of in segments on the ground. And so seeing the cameras on orbit and seeing them deploy was amazing, because that antenna hadn't fully been tested on the ground as one giant assembly. It had been tested very deliberately, very carefully, very intentionally on the ground. We were sure it's going to work, but seeing it kind of in space all together was really wonderful.
And on that same topic, how fulfilling has it been to see something like literally spread its wings for you after all those years of work that you put into it?
Oh yeah, so personally, I'm very used to seeing the satellite in a clean room in a very controlled environment. We're all wearing hairnets and gowns and gloves, and we're cleaning it and making sure that everything we add is very documented and perfect, or as perfect as can be. And seeing it in space, it's very gratifying, but part of me is also like, who let this happen? Why is it outside of a clean room? Because to me, I'm so used to seeing it in a clean room, but it's so exciting to see it doing what it was meant to do, right? It's going to be doing science that'll help us understand our home. So that'll be great.
Home is where the heart is, for sure. And Christine, you've had many exciting adventures, and also the SWAT team had a lot of hurdles because COVID happened right in the middle of really your processing.
Yeah, so SWAT has gone through lots of phases of integration and testing, and kind of in the middle of all of it, the pandemic hit. And our partners, half of the satellite was built in France. And so it added some new challenges of how do you build a satellite with our partners who can't travel to us, and we can't necessarily travel to them. And we figured it out over time, but at first it took a lot of flexibility. We learned how to video conference in the clean room, so our French partners would watch us assemble various parts of the satellite that they had some authority over, and it was really exciting. But it was sometimes difficult to be like, oh, this team in France is are the experts on this thing, but we need to be doing this here in LA or in Pasadena, and it just caused some flexibility, but it was definitely an adventure.
Yes, an adventure worth taking, for sure. Yeah. And now we're just starting to see the results. And we got some really great questions over the last couple of weeks from our viewers, and you would just be the perfect person to answer some of these. Are you up for it?
Yeah, let's do it.
All right. Okay, great. First question comes from Muhammad on Twitter. Congratulations on a successful in-orbit deployment of SWAT. How long does it take to fully deploy the solar arrays? Is this spring back effect normal in solar array deployment?
But I have to say, I'm not an expert on these solar panels because they were built by our French partners. but the solar panel deployment does have about 2 phases. There's like an initial kickoff. So the solar panels are kind of kick off, and then there's like a spooling, like a wire that gets spooled in, and that deploys the solar panels fully. It takes like 20 to 30 minutes, about in that order of magnitude, to deploy, but that is relatively quick when you want to be very careful in space and make sure these work. But our partners have done this many times, so it's exciting to see that they successfully deploy.
And it takes a little while, doesn't it, Christine? It's not, just automatic in 60 seconds they're deployed. I mean, it does actually take some time, and even sometime over the course of days.
Yeah, so we don't always have communication with the satellite, and so you carefully plan activities so that you know that you're going to do really big activities like that one, like deploying a solar panel. You do a lot. You could do preparation for weeks just to do it for like 30 minutes to deploy. And the other part of it is you don't want to break anything, or you don't want anything to snag. With deployables, snagging is always a concern. And so we design away the chance of snagging, but the faster you deploy something, the more likely something is to crack or snag or something. So you want to kind of do it in a controlled way as much as possible. But that initial kickoff is important because you kind of want to get away from the body as quick as possible.
Awesome. Okay, so next question comes from Travis Ramirez on YouTube asking, if you could have included one more instrument or experiment to do with SWOT, what would it be?
Okay, so I'm an engineer. I like engineering and building things. I'm not a scientist, so I don't have a good understanding of what sort of climate science might be the most valuable. But SWOT creates a lot of data, and that data is hard to get to the ground because we can only talk to SWOT during some time. We don't have live streaming from SWOT all the time. And so what I would do is actually add another technology called optical communication to SWOT, which is essentially using lasers to communicate data back to the ground. And that helps us get a higher bandwidth of data to the ground. So I think it'd be really cool to have SWOT communicate with lasers back to the ground. Space lasers are always kind of fun to think about. But that's what I would add. But I'm not a science expert. I'm just an engineer who wants as much data as possible.
I think lasers in any capacity sounds really cool.
Absolutely. And it's a technology that JPL is going to launch on the Psyche mission soon. So it's coming. It just didn't make it onto SWOT.
Great. Next question comes from Rachie on Instagram. What made you want to become an engineer? And do you have any advice for anyone out there who is interested in this field?
Yeah, so I was super, super lucky to be a student in the Girl Scout sailing program in Houston, Texas, as well as a first robotics student. And those two programs, well, sailing taught me aerodynamics and like mechanics of a sailboat, and the robotics taught me engineering and a little bit of that. And so I got exposed to a lot of STEM concepts without even knowing I was being exposed to it. I just thought I was sailing and I didn't know I was learning STEM. And through those programs, I slowly learned that I wanted to be an engineer. Now, the advice I would give to someone is to follow your curiosity. I was really privileged to have access to those programs, but if you're curious about something, follow that curiosity and don't let a lack of skills always stop you. There's plenty of resources online, on YouTube, on all sorts of places where you can learn something, and don't be intimidated that you might not know how to use a tool. Someone is always willing to teach you, or you can maybe find a resource in your library to follow your curiosity and learn the tools you need to follow your curiosity.
That's so brilliant, Christine. I was a Girl Guide in Canada as well. And so I absolutely loved even just going on nature walks and just getting out there and figuring out what it is that you're passionate about and what you love.
Yeah,
all right,
absolutely.
we've got some more questions coming in. So how far from Earth is SWOT? And that's from Akawi Returns on Instagram.
Yeah, so SWOT, as you said, is about 550 miles above Earth. It's kind of in a low Earth orbit, which allows us to collect that really good science data without being too far away.
And is it always going to stay at 550 miles?
It'll be about there for the rest of its life, but it will switch from like a holding orbit for calibration to a slightly different orbit that lets it see all of Earth's surface water.
Okay. And then we've got another question coming in from Jeremy on Instagram. It's hard to tell from photos how big SWOT is. Can you help us better understand how big this thing is? And it's hard too, because this is the 1/3 model behind me, and you can't even hardly see it because basically it's just the center part of it, and it's not everything that's included.
Yeah, so a lot of people will compare it to an SUV before it deploys. So it's about the size of like a really large SUV before it deploys. When I think about it, I think of it more of as like a small school bus. So that's about how it is when it's on the top of the rocket. And then when it goes to space, the solar panels and the antennas, the Karen antennas deploy, and it ends up being about the size of a half tennis court. So it becomes quite large, like it has a large footprint once it's in space, but that doesn't fit in the rocket, so it has to kind of go up all packaged together.
And then everything slowly, surely, as it's been doing over the last 40 days, starts to unfold.
Yeah, absolutely.
Piece by piece. All right. So now I know that you are a big advocate of women in STEM, and I heard you talk a lot about your year in France. We got to spend a lot of time on Instagram together, and I loved seeing all of your posts. So tell me a little bit about how that experience was, spending the year in France working on SWAT with that team. And it was a team, the mechanical team was made up of women, which you also said was just fascinating.
Yeah, absolutely. So me, along with some of my colleagues, we actually moved to France for a year to help integrate the American half of the satellite with the French half of the satellite. And that was an incredible experience. We had worked with our French partners remotely over the pandemic, and meeting them in person was really exciting. And personally, it was really exciting because I got to explore France, and I got to work in a new facility and see how they built satellites and kind of mesh JPL's processes with our partners' processes at CNES. So that was exciting. And then the JPL mechanical team is mostly women, and we actually got to go to France and meet many of our counterparts who are also women. And STEM is a male-dominated field, but it was exciting to see like that some of the CNES project was managed by an awesome woman. And I love rock climbing, and I actually talked to her, and she's a manager high up in her career, and she had grown up rock climbing in France, and we got to bond over that and just learning and seeing all of our colleagues on the French side and the American side kind of merge cultures and work together in various ways was really exciting.
And science has no boundaries, and that's what's so amazing about projects like these.
Absolutely, especially earth science. We all care about making sure that Earth, we know as much as we can about the climate. And so our partners are as invested in that as we are.
Well, thank you so much for joining us here today, Christine. It's been such a pleasure working with you, and I know that you can't wait for that data to come down. Every little piece that comes down is just as exciting.
Yeah, we've gotten the first little bits of data, but I can't wait for the satellite to be calibrated, and we'll get real data. And it's been an honor and a pleasure to work on SWOT with the entire team here at JPL and across the ocean.
Well, thank you so much, Christine. And thanks to all of you guys for being here with us today. If you want to learn more about the SWAT mission, you can follow us here at NASA JPL and also at our sister station at NASA Earth that Christine has been on today. And it's a really great mission, so I hope you have the chance to go back and forward with us as we look forward to that first science data coming down here in just a few months. And remember, at NASA Earth Science, your home is our mission. Thank you so much for joining us here today, and go SWAT!
Go SWAT!